In this video, I want to talk a little bit about the bank example. And in the bank example, we're using arrays. The key thing to remember here is that we're not using arrays as in an array of integers or an array of booleans or anything that's pretty standard. We're using an array of objects. And as you do more and more object-oriented programming, you're going to recognize that doing an array of objects is actually a pretty good way of storing data. So the first thing that you're going to see is that I'm going to have an account. An account class here is just a set of, you know, information, a string contains the name, which is like Jody's checking or Jody's savings, an account number, which is just exactly that, the account number for the class itself or for the account itself. And you're going to see that there's going to be an array of ledger entries. Think of the ledger entries as just something like your statement that you would receive at the end of every month, or if you log online onto your bank, you can see, when you did a withdrawal, when you did a deposit, what the amount was, what the amount was at that given time in your actual account. Now, because we're using an array here, there is a limitation on this. At least in the way that I wrote it initially, because I wanted to demonstrate this fact as well. And the limitation is that you can have 100 entries per account. Now, realistically, I would make this a much larger number if I was going to actually use this. In addition, I would probably have the ability to expand my account. But for the sake of argument, and one of the things that you need to understand about arrays is that you do have a limitation because you set the amount of entries at the beginning. And that cannot be changed unless you create a separate array and copy all of the entries in from one array to another, which is not a cheap operation to perform. You're going to see that I have a default constructor which sets the account name and number to the empty string, the current amount to 0, and the ledger entry count, which is just a variable that says, hey, this is how many entries I have for this account so far. You're going to see that I also have a method called initLedger, which I'm going to use in the overloaded constructor as well. In the overloaded constructor, I have the name, the account number, and the amount that are being passed in as parameters. All right, so I have the name, the account number, and the amount. That's the current amount that's in the account to begin with. I still set ledger entry count to be 0, and I call initLedger like before. InitLedger declares an account. All right, so I declare an account that has a series of ledger entries of them, 100 to be exact in this case. And I create a new entry which holds the current amount in the system. So when I do an initLedger, I'm creating the account for the first time. So just by default, there's going to be a deposit, and it's going to be the initial deposit, which is going to be the current amount in the entry itself. All right, so if you look at when I actually instantiate this in the bank example, all right, I'm going to pop back to this in a second. But if you look at this in the bank example, you'll see that what I've done is down here, oops, where is it? I've lost my, here it is. I created a new account. I called it Jody Checking, gave it an account balance, and gave it an initial amount. I did the same thing for the savings account, Jody Savings, 1102, 15,000. Again, I just wanted to create accounts that already had some values associated with them so that I can proceed with the testing process. Now back to account. So what I've done is in my account, I have my default constructor, my overloaded constructor. Then I have my initLedger, which creates the account, adds an entry into the ledger with the amount that I'm initially depositing into the account itself. I have a method called deposit, which takes the current amount that's in the account, adds the amount deposited to it, and then I create a new ledger entry. Again, remember, not only do I have to create the, where is it? Create the ledger entry array, but every time, since this is an array of objects, every single time that I use it, I have to create a ledger entry or a ledger object. Okay? So what I do when I do a deposit, I add the current amount, the amount deposited to the current amount in the account. I create a new ledger entry count object, and then I add an entry into it. So my add entry is going to say, oh, I need to add a deposit. This is actually a reason. I don't provide a reason for the deposits just because it's a deposit. The amount, and then I specify what the new current amount is. The next thing is I have to increase the ledger entry count so that the next one that I instantiate is going to be an empty space in my array. Same thing for the withdraw. All right. So every single time that I withdraw something from this account, I'm going to specify the current amount and subtract whatever amount I passed in. I create a new entry in my array for this particular account, and I add the entry to the array itself. It's a withdrawal. If you're doing a withdrawal from an account, you have to specify a reason. You then specify the amount, and I pass in the current amount. Let's take a look at what the ledger entry actually looks like. A ledger entry, again, just think of it like a statement, has an amount that's in the account, a reason for a withdraw. Generally, deposits are just null, so I don't need a reason. The deposit withdraw amount, the amount to deposit or withdraw, and the entry type. Is it a checking or is it a savings? All right. Probably not quite as necessary because I'm specifying two different types of accounts, but maybe in a future expansion I would want to be able to distinguish this for some reason. I have my default constructor, which initializes the entry type to null, the reason to null, the amount to 0.0, and the deposit amount to 0.0. Realistically, I'm probably not going to use the default one very often. The one that I'm actually using, I am using the default constructor a lot. What I'm using more frequently, though, is the add entry. All right, so when I add an entry, I say, okay, I want to set the entry type, checking or savings, the reason, if it's a withdrawal, why am I withdrawing that amount, the amount that I'm withdrawing or depositing, and the current amount in the checking account anyway. The last thing that I want to do is actually display an actual entry in the ledger. So remember, this is an array of ledger entries. Back here in my account, I have the ledger entry array. So for my checking account, every time I do a deposit or withdraw, I'm creating one of these objects. For my savings account, every time I do a deposit or a withdrawal, I'm creating one of these. So each type of account has this an array that can hold 100 objects in it. Now, back in the account, you'll see the last thing that I have is my display ledger entries. What I want to do is I want to go through and display every single one of the entries that currently exist for this particular account. And I do that by going through my array. Now, since I'm keeping track of how many elements I've created in my array through this ledger entry count, I'm able to actually say, okay, I want to go from 0 to the current entry amount. Remembering that the current entry amount is always an empty space. So I have to do one less than that, which is why it's I less than ledger entry count. And in order to do this, I take my object, which is my account ledger of I. So for the first one, if it's the checking account and I have a deposit, I'm going to display the 0th entry, which should be the initial deposit. Same thing for the savings. All right. And then down below, I have my accessor and mutator methods. Now, back in the bank example, what I want to do is I've created a menu that's going to allow me to, deposit into checking, withdraw from checking, deposit into savings, withdraw from savings, etc. All right, so I'm going to have two types of accounts, a checking account and a savings account. You'll see that I have a constant here, which is exit program, which is a 9, and I have my scanner as usual. In my constructor for my bank example, I'm creating two accounts, the Jody checking and the Jody savings, and I'm providing an initial amount of $5,000 for checking and $15,000 for savings. The next method that I have is the display menu. You'll note that this is a while loop. So what I'm doing is I have a response. While the response is not to exit the program, which exit the program is a 9, then I'm going to display the menu to the user. Deposit into checking, withdraw from checking, deposit into savings, withdraw from savings, display checking transactions, display savings transactions, or exit. I prompt the user, and then based upon what value they enter, I execute some menu selection. All right, so I'm doing that via a switch statement. In the first case, I'm depositing into checking. So I prompt the user for how much they want to deposit. Notice that I'm also checking to make certain that they didn't enter in a negative value. Because if they're entering a negative value, I don't want them to be able to subtract from their checking account because that doesn't make sense. So I keep telling them until they get it right, enter an amount that's greater than 0. If I'm withdrawing from the checking, same thing again. I'm going to already be doing the subtraction, so I don't need them to enter in a negative number. So I'm going to keep prompting them over and over again. Okay. Additionally, once they finally enter in a reason for, or enter in a positive amount to withdraw, I have to ask them for a reason. Why are you withdrawing this? Is this for rent? Is this for a credit card payment? Whatever it may be. And you'll see that I store that inside of reason. Now there is one issue here. When you do a next console.next double, it does not consume the end of line character. So in order to consume the end of line character, I need to just, eat it up. And that way it allows me to actually have my prompt for the reason for the withdrawal. If I don't have this statement at line 81 inside here, what happens is that it says enter the amount greater than 0, or enter the amount, I enter the amount, and it totally skips over the next line because what it's doing is next line is consuming the end of line that was left over from the next double. All right, you can do a Google search on this, and there's lots of explanations out there on what happens. The solution is add in a next line just to consume that extra end of line character. All right, once I have my reason, I tell my checking account to withdraw. For my savings, if I'm going to do a deposit, I tell my savings to deposit a certain amount. If I'm withdrawing from savings, again, I'm doing the same amount. I can display the entries for my checking account, display the ledger entries for my savings account, and that's it. All right, now the only thing that I'm doing in main is I'm actually executing the bank itself. So I'm instantiating an object called bank example app bank, and I'm saying new bank example app. Okay. Then I'm calling display menu. Display menus again jumps back up to this top loop here and says while response not equal to exit program, and go through it. So when I run this, you'll see that at the bottom down here, and let me expand this a little bit, I start off with my menu. All right, now if I display the checking transactions, which is 5, you'll see that I currently have $5,000 in it. If I display my savings transactions, you'll see that I currently have $15,000 because that's just what I instantiated into the object itself. So let's deposit into checking, and let's put in an amount of, let's start off with negative 100. All right, you're going to see that's going to prompt me over and over again until I get it right. So I'm going to enter in a $1,500 deposit. All right, so now let's display my checking transactions. I now have $6,500 in it because if you scroll up, I have the 5,000 and then the 1,500. All right, same thing for savings. I'm going to withdraw from savings. Let's do a withdrawal from savings, and let's do a $10,000 withdrawal. Let's do $10,000.50 just to show that I can do decimals. All right, enter the reason for withdrawal. Let's say that I'm paying off a loan. So now if I display my savings transactions, you'll see that I now have $4,999.50, and the reason for my withdrawal is to pay off a loan. I also have my original deposit into my savings account, which was $15,000. So every time that I add something in, I'm adding another element to my array, which is an object, which is one of these ledger entries. All right, so if I do one more, let's do a deposit into savings, which is 3, and let's deposit, I don't know, $2,500. All right, so now if I display my savings transactions, you'll see that I now have $74.99.50, and I have 3 transactions, which means that I have 3 elements in my array. Remember, I can only have up to 100 transactions in any given account of each type. All right, so that's the bank example. Let's take a look at the bank example using an array list versus an array. An array list it's going to be the exact same entry list here, but I'm going to be using an array list instead. In order to declare an array list, I specify it as an array list, and then inside of these brackets, I specify the type of the elements of the array list. In this case, it's going to be an array list of ledger entry objects. All right, I'm still calling it my account ledger. Max entries doesn't really matter anymore. In fact, I could just remove it completely anyway. All right, now the only difference in here is when I need to instantiate my array list. So just like my array itself, I need to actually create it. So I need to allocate some space. Inside the array list, I just say new array list and I specify a ledger entry. This is going to just create a ledger entry. Now, there are overloaded constructors which allow me to specify, if I want to initially create 20 of these or whatever. The issue with array lists is that there's a very positive issue in that they will automatically expand and contract as necessary. The issue is that's also expensive, right? If I'm inserting or if I'm having to constantly copy over elements into an array list, because what is an array list underneath? It's actually an array. So it's doing the copying of the elements of the array in, every time it has to resize. So that is a sort of expensive operation that takes place. But, for this example, it's really not that bad. Notice that in order to add a new entry to my account ledger, I need to say new ledger entry. I call my constructor, and then I say get. So I have to use my add method and specify what I want to add into my account ledger list. And then if I want to perform an operation on it, I have to get the current entry using the get statement, and then I call the add entry. All right. So what that's saying is give me the first object ledger entry out of this list, And let's do the add entry method call on it like we did before, which is a deposit, initial deposit, a current amount, and current amount. Right? It's the same thing when we're doing a deposit. We're creating a new ledger entry and adding it to our account ledger list. I have to get that particular entry in order to call the add entry. So this could actually be broken into two statements, right? This could be a ledger entry equals account ledger dot get ledger entry count, and then I could just say entry dot add entry. All right, it's the same statements. I'm going to go back to what it was before though. All right, because it just makes it easier to call. I'm basically doing multiple statements in one. I'm getting the entry and then calling the add entry. All right, so that's what's actually going on there. The display is just a little bit different as well. And we're using the iterator for loop. All right, so in here we have a for loop. And what this does is it goes through my account ledger list, and each time, as long as there's an entry in there, it specifies the object in entry. So what do I do is I specify, hey, whatever entry you're on, if you're on the first one, display that entry. If you're on the second one, display that entry. All right, so it's looping through and it's keeping track of all of these elements. It basically stops when there's no more elements in the account ledger list. So I don't even need to know how many entries that I have in my list right now. This for loop is going to specify it for me. All right, and those entries are the same. You can see again, if I just do a 5 and a 6, my deposits are the same. All of the operations are going to be the exact same thing. I'm going to deposit into savings, let's say $1,400, and then I'm going to display that. So again, it's the exact same operation, $16,400 right now inside of my savings account. Go back and spend some time playing with the operations of an array list. You're going to see that there's a lot of additional operations that for an array you would have to implement on your own. That's why Java created these, because in the past we always had to implement our own operators in our array list. But later on, when we're talking about generics and collections, you're going to see that this is going to be an actually very useful tool for you. So that sums it up for what I at least want to talk about in the videos for the arrays and array lists. If you have any questions, as always, please don't hesitate to contact me.